This topic might be, I feel like, the most unfamiliar out of all the topics that we've addressed so far in the review section, so I'm going to make some detailed notes for this. First, parametric equations. What are parametric equations? Normally, for regular functions, we have a function f in terms of x. And so, we'd have like y equals some function involving x. That's a normal normal function, where x is the independent variable and y is the dependent variable. You just choose x values and then y is chosen for you. That's why x is independent, because you can choose whatever you want, and then y is the dependent variable because it's decided based on what x is. So that's a normal non-parametric equation. A parametric equation is where both x and y are dependent on some other variable, and we'll call it t. That's the parameter. They're dependent on the parameter t. Usually it's like time. And you can get some really, really crazy looking, cool looking graphs that aren't necessarily functions, but they're relations. So let me write that down real quick. I think I might have said parametric functions. I meant parametric equations, because they're not functions. So I don't know if I said functions or not. I can't remember. So it's called a parametric equations. Parametric equations are equations where both the x and the y coordinate are dependent on a third variable called a parameter. Let's take a look at what the heck I'm talking about. Let's do this. I'm just gonna show a list of some parametric equations. They're pretty much like two different functions, right? You have a function for x and a function for y, and they're both dependent on t. So that t is going to be the parameter. That's usually what they denote it as. So let's see what happens. Let's example 1. So here we are. If we cover this up, we have a function of t. A function x being a function of t and y being a function of t. That's saying it's dependent on that. And then we have some restrictions on our domain of t. So like t can only be 0 or bigger. So if I were to graph this, I'm just going to go straight old school back to a table of values, except this time I have t and then x and y. So I never actually see t on my graph. I never see it. I only see my x and y coordinates. So it's kind of like time. That's why it's called t, because you don't really see time. You just see what happens after. And I don't know what I'm saying, but hopefully you understand what I'm trying to get at. We have 0. I'm just going to do 0, 1, 2, 3. Let's actually no. I have a square root, so I'm going to do perfect squares. 0, 1, 4, and 9. Just so I can deal with that easily. So if I plug in 0, I get just 0 for x and 0 for y. And then maybe I'll plot it at the same time. So there we go. That's 0, 0, 0. I would do it in red. And then I have plug in 1, and I get 1 and 1. Okay, fair enough. 1 and 1. And then plug in 4, and I get 2 for x and 4 for y. So 2 comma 4. 1, 2 comma 4, right? 1, 2, 3, 4. What is this? This is crazy. Plug in the 9, and I get 3 and 9. So I go out to 3, and I go up 9. I don't know if that's 9 or not, but 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And normally I'd be plugging in all the stuff in between, but it wouldn't come out evenly, so I just didn't do it. This is half of a parabola, right? Normally we have both sides. This is half of a parabola. That's just because t is like that. So this parametric equation does exactly what y equals x squared for x greater than or equal to 0. These two things are the same. It's just a different way of representing this. In other cases, and we'll see them, in other cases, parametric equations can do stuff that normal functions cannot do. And you get some really crazy looking graphs, like cardioids and flowers and cool looking things. So that's for the first example. That's just graphing these parametric equations, just to see how they work. More examples to come.